Hi, everyone. Thanks for joining. And thanks, Michelle. For the last 10 years, a lot of developers have been told that only NoSQL databases scale or that SQL was hard or bad. Now that there are SQL databases that scale and provide joins and provide resilience and transactional integrity and even low latency, I think a lot of developers are realizing that there really isn't a better general query language than SQL. However, if you started out in a boot camp or you learned MongoDB as your first database, you might not actually know SQL. So this is a NoSQL for NoSQL developers. Don't roll your eyes that far back in your head. You'll give yourself a headache. If you want to get in touch with me afterwards, then you're welcome to. You can find me on Twitter at @ACOliver. You can also find my email address, aoliver@yugabyte.com. And I've been doing SQL stuff since forever, really. I actually started out with DBase 3 Plus, which was a pre-SQL, or it wasn't even a SQL database. Without going, so Yugabyte is a company founded with the idea that the next major decade is going to see a lot of systems of record in enterprises moving over to the cloud and needing to distribute some of the load and be able to scale and all that kind of stuff. It's used by both smaller companies and Fortune 500 companies alike, retailers, advertisers, financial service companies, telecom, etc. So in short, if you need to scale your transactional workloads to the cloud and have it all scale, grab Yugabyte. But today we're mostly going to focus on SQL. Just to make sure we have a place to run it, we'll install Yugabyte, get familiar with the command line tools, look at a sample database, load it, run some SQL queries, and being the masochist that I am, I'm going to do it all live right here on the console. So first, let's get Yugabyte running so we have a place to run our SQL. What the heck is a Yugabyte? Well, YugabyteDB is the only database that can scale to an entire Yugabyte of data. Actually, Yuga is a Sanskrit word that roughly translates to a long period of time or an age. And when we put it with byte and DB, we can trademark it. So Yugabyte is, in essence, a NoSQL backend for scale and performance, but it adds to it the front end of a full-featured relational database, namely the PostgreSQL database. It combines this with the ideas of Google Spanner in terms of how you can run SQL at a global scale while keeping consistency. A lot of other databases that give you scale don't give you consistency, where Yugabyte does. It supports all the full-featured capabilities and transactional integrity you'd expect from a relational database management system while giving you single-digit latency and scale at the back end. Basically, it lets you have your SQL and scale it too. And best of all, it's open source, so you can download it right now. Today, we're going to do everything at the command line, but I want to make sure you realize that while developers tend to hack on things at the command line, the operations people tend to use Yugabyte platform to deploy, manage, monitor Yugabyte DB. Moreover, if you're a developer but not a command line junkie like me, you can always install SQL in Workbench or tools like pgadmin. There are hundreds of other SQL workbenches like pgadmin, and generally if it works with PostgreSQL, it'll work with Yugabyte. And if you haven't seen pgadmin, this is actually pgadmin. Apparently I'm running a point release behind. This is a pgadmin connected to my Yugabyte instance. So this has nothing to do with SQL, but if you install most databases on your laptop, including Yugabyte DB, and you haven't already upped your file handle settings, then it'll probably fail. So Yugabyte uses a lot more than the default 256 files on Mac, or you can also, or on other operating systems. If you check out the Yugabyte install guide, you can get the Mac instructions. The docs don't tell you this, but you may also want to do a ulimit minus n, and make sure it's at least 6,400 or more. Particularly if you already had the console open, sorry, 64,000 or more. So if you're on a Linux distribution or what have you, then you can look up how to do that on your favorite Linux distribution. Any of the databases will all have the same sort of issues. So whether the instructions are for Oracle on Red Hat, it'll still work for Yugabyte or PostgreSQL or whatever. If you haven't installed Yugabyte, that's one of the first things that we can do. You can install Yugabyte on Linux or Mac natively, or you can install it in a Docker container. Each version of this gets the database and starts an instance. If you're not viewing this live, then verify you're getting the latest and correct version of the commands by going to download.yugabyte.com. I just cut and pasted them from here. If you're on another database, make sure you've got that installed and are ready to go from there. Yugabyte comes with a command line utility called YSQL shell. You can just run it. The / is help, and I'm going to just go ahead and run it right here. The / is help. And you can hit Q to get out of the more. /Q will actually quit out of the shell entirely. So before we can query, we need a database. We're going to install the Northwind database from the Yugabyte documentation website. Ironically, it was one of the first SQL databases I worked with because it is infamously the sample database from old versions of Microsoft Access. It's actually one of my favorite example databases. It has order line items, products, categories, employees, customers, all the concepts that most people are familiar with if they've ever seen a business. To get the Northwind database, we'll grab it from the above download URLs. You can either wget them or right-click them. Next, run the Yugabyte SQL shell or PGSQL, or sorry, the PostgreSQL. And if you're on PostgreSQL, execute the create database statement and then connect to the Northwind database. And I'm just going to go ahead and do that right now. I've already downloaded the scripts, so if you haven't, you'll need to do that. But I'll go ahead and create database Northwind. And then I'll connect to it. I'll go ahead and run the Northwind ddl.sql. That creates the database. And then I'll go ahead and run the Northwind data.sql, which loads all the records into the database. And it's done. Again, this has nothing to do with SQL per se, but with the Yugabyte, using the Yugabyte shell. If you're using a Postgres, or if you're a Postgres user, they'll be the same commands. The main ones that we'll be using are connection, list tables, describe tables, execute scripts, and of course, quit. Once you've imported the Northwind database, you'll be able to list the tables. So let's go ahead and do that. When I type \DT, I can look at all the tables that were just created and loaded by my script. And if you wanted to, you could look at those scripts and see what's in them, and you'll just see that there are a bunch of SQL statements. So now we're able to list the tables. Now let's look specifically at the US states table. So if I type US states, it'll show me what the fields are and the types in this US states table. So we've got a state ID, a state name, state abbreviation, state region. The primary key, which is what uniquely identifies this row, is the state ID. By the way, if you're not a command line junkie, again, you can get this same information in pgadmin. So here you see that my Northwind database is now here after I've loaded it. And you can go down to schemas, you can go down to tables, and you can go down to US states, and you can see the definition. It actually shows you the SQL used to create this table. So that's just an alternative you have if you're not interested in becoming a command line junkie. So let's do a select statement. So I'm going to do select star from US states. Nice concise queries. I know about how many rows are in here. I can hold down enter if I want to just keep going. There you go. You've got the states. I'm wondering where the 51st one came from. I'm sure if I scan through here, I can find it. But there you go. Oh, it's got Washington, D.C. in here as a state. So select is what tells the database that we're going to retrieve records. Star means all of the columns from the table. And the from clause is where we list the tables that we're going to query. In this case, we just listed one, US states. All SQL statements end with a semicolon. So that's our whole statement right there. Let's do a projection and a condition. Here we're going to get all of the state abbreviations from US states table where the region is south. So we'll type select state ABBR. And when I put something other than the star in here, that's a projection, a subset of the fields from US states where state region equals south. So here I got all of the ones from the south, you know, the civilized part of the country. I live in Savannah, Georgia myself. This time, instead of doing star, we're doing in SQL what's called a projection or a list of columns. Our list just includes the state ABBR field. If we were doing multiple columns, we'd put a comma in between them. Where is how we specify a list of conditions. In our case, the condition is state underscore region, that's the field, equals the string literal south, which is delineated by the single quotes. And south is just the value. If we look at these fields, you see that West Virginia has south in the value for state region. So we said, give me all rows that have south in the value for state region. And by the way, I only want this column, this field. Now let's look at the products table. So let's get the product name, number of units in stock, and units on order from the products table where the product's been discontinued. So I'll type select product name, units in stock, units on order from products where discontinued equals 1. So now I've got all the discontinued products that we carry here at Northwind Traders. Let's look at the products which are discontinued but still have units on order. Because why are we ordering a product that we're not going to carry? So let's do that. So if we type select product name, units in stock, units on order from products where discontinued equals 1, we get that. And if we then add and units on order by the way, if you hit the up arrow, you go back to the previous SQL query. Where units on order is more than 0, then we get 1 row here. And unfortunately, it looks like we've discontinued our Thai beer. So so no more Chang beer coming to us. So we now have 2 conditions. They both must be true. Discontinued must equal 1 for each one of these rows, and units on order must be more than 0. There are other operators that we could use, like not equals. So we could do the bang equals, and greater than less than. So less than or more than 0 would also give me discontinued items in our data. We can also use or instead of and. So if I do this query, where discontinued equals 1 or units on order more than 0, then I get this list. So instead of and, which I did in the first query, I changed that to or. So now I've got more records coming back because I'm getting whether they're on order regardless of whether they're discontinued. So yes, I want things that are discontinued, and yes, I want things that are on order. I don't want things that aren't discontinued that don't have things on order, essentially. So I said select product name units in stock, units on order from products where discontinued equals 1 and units on order is more than 0. But then when I change it to or, I get additional records because either one of them, if either one of them is true, sorry, I was on the wrong slide here. If either one of them is true, then it's included. So discontinued equals 1, units on order more than 0. If either of those conditions are true, then the record's included. You could also do a similar, you could get the same results roughly by saying select product name from products where discontinued equals 1. Union is another SQL keyword saying add these results together. Select product name from products where units on order is more than 0, and then you would get back the same results, just the first one's more efficient in general because you've got 1 query executing instead of 2 and then being added together. So let's look at the orders table. So if I look at the orders table, I've got order ID, customer ID, where it's shipped to, the country it's shipped to, city, that sort of thing. Let's look at the related order details. So if you've got an order, think of the order sheet. You've got an order and it's got that header information. That's roughly our orders table. And then it's got a list of the products that you've ordered. That's roughly the order details table. Now, let's take some of the columns from orders, some of the columns from order details, join them together. However, there are a lot of rows, so let's stick to only orders shipped to Portland. So what we're going to do here, select o.order ID, o.customer ID, o.order date, and then we're d.product ID, d.unit price, d.quantity from orders, which I'm going to alias to O, and I'll talk about aliases in a moment. Inner join order details D on order O.order ID equals D.order ID, where ship city equals Portland. And anything in the single quotes is case sensitive, so be careful. And so I get back this set of results. So, so I'm getting back some of the columns from the orders table, some of the columns from the order details table, and you'll notice that these are both of these result rows are from order 10708. So these are 2 line items from that same table. Or sorry, from that same order. So I just did an inner join. The inner join matches on the order ID column. So every order ID that has 1 or more matching order IDs and order details is included in our set. Additionally, we've used aliases on our tables. So in the from clause, we aliased order to O, so I don't have to type order dot. In the inner join clause, we connected the order ID columns in the on sub clause. So that's how I tell which records match together from which table. And so this little graphic from Wikipedia, you see A and B, and you see that it's the intersection of them that are included. In the orders table, the order ID is guaranteed unique. It's called a primary key. In the order details, it is a foreign key. Essentially, an inner join is an intersection or the part in the middle. So we explicitly used an inner join clause, which I strongly recommend. But you may find that some queries where there are 2 tables in the from clause and the in the where clause, they match the columns as an implicit join. So I would just basically this query, I'd move order details to from. I don't have an explicit inner join clause, but because I matched order ID from orders to the order details table, you can actually see that in this case, it will do a inner join, but it's an implicit inner join. It'll return the same results. I recommend you use the explicit inner join. When I learned SQL, this was actually how you did it, but these days it would be better to use the explicit form. It's clearer, better self-documenting and what have you. Now let's do a group by. We're gonna join the orders table with the order details table, but we're gonna group the order ID from we're gonna group by the order ID from the orders table. Here we're just gonna try and find out how much cash we're gonna make per order. So I'll do the same setup and I've got my same inner join. I've got my same ship city. I'm gonna add group by o.order ID. And then I'm gonna go up here and change my projection and instead of just listing a bunch of columns, I'm gonna give the order ID and I'm gonna do a sum d.unit price times d.quantity. And make sure I spelled quantity right. All right, I'm gonna run that. And so now you see the order IDs and you see a sum of the ones that had in our result set that had the same ID. So what it's gonna do is on this row, it's gonna take the unit price times the quantity. On this row, it's gonna take the unit price times the quantity. And since they're grouped by order ID, the sum is gonna add that calculation together. So you could just, if you wanted to, without the group by, you get rid of the sum, you could just do unit price times quantity, and that would work per row. But then when you want to group them into the order, then we use the group by. And when we want to sum all the rows in the group, we use the sum function. So the sum function adds up all the columns for the group. In our case, we're using a mathematical operator to multiply price times quantity. The group by basically says for each order, treat all of the line items in the order details as a group. In addition to sum, we can count the line items. So in this query, we're gonna, instead of doing the sum, we're just gonna count d dot order ID, so from the details side, and we're going to change this to count. What this does is tell me how many line items are in each order. So some of these have 3 products being ordered, some have 2. So how many rows are there in order details for every row in orders? In addition to using count for group by, you can count all of the rows in a table by just doing count 1. So I could do select count 1 from US states. I could also do count star, and that gives me the number of rows in the table. And this counts the, this is null safe essentially. If I had a null, if this were a nullable column, meaning the column contains nothing, then this is, gives me 1 per row, regardless of whether everything's null. In addition to inner joins, there are outer joins. So perhaps we want all the products whether or not they're included in an order. And we want to count how many orders there are for a given product. So 33 orders contain that pate. So if I do select p.product name, count d.order ID from products p, left outer join order details d on p.product, helps if I spell product correctly, product ID equals d.product ID group by p.product name. So here I'm counting the number of orders per product. We see that there's 33 orders for pate. If I don't want to sit here and hit enter through all of these, I can hit Q. That doesn't exit out, /Q would exit out. So at the moment, there are no products, if I go through this list, that don't have at least 1 order. So every product I carry, I have at least 1 order from, 4. A left outer join includes everything from one table, whether or not it occurs in the other table, but it includes the things from that other table that match. So it only includes the rows in table B if they're in the first table. In our case, we have the products, we have all the products, but only orders for those products. So by grouping on product name, we're able to list the product name, but count how many orders there are for that product by counting the order ID that contains that product from the product detail, from the orders details. We're assuming that there are not multiple lines in an order for the same product. Otherwise, I'd have to join up or distinct against the order ID, but that would be a more complicated query and kind of beyond the intro that we're trying to do here. So let's go ahead and insert a new product. So I'm going to do a select star from products where product name equals tofu. Again, need the tofu. So I got some tofu. Then I'm going to select max product ID from products. And I get the number 77. So now I'm going to go ahead and insert into products values, and I'm using the values from the row I got back in order. I'm going to give it its own primary key, so I want a different ID. So 77 is the max. I'll do 78. I'm going to call it extra firm tofu, which is my preference. I don't like the mushy kind as much. Sometimes it has its place, but not generally. I'm going to do 6 is the supplier, 7 is the category. And then I'm going to do 14 ounce as the container size, 1.99. The price 50, 0, 0, 0. And now I've inserted a row. So if I then do select star from products where product ID equals 78. I get my extra firm tofu. I've now inserted that record. Again, select from products was just so I didn't have to look up the other subtables like categories or any of the other field values. We just used the tofu as a template. The max product ID was just so I could add one to it and generate a primary key. This isn't a safe way to do this on a system with multiple users, but that's a much longer topic. The core was my insert statement. I did this with the simple form, just using values clause and setting the columns in order of the table definition. However, the correct or cleaner way is to include the field names that I want to set values to. This is safer, especially if my table definition changes somewhat. It's irrelevant in a simple data set with one user where any change of the table I would have done just now, but in general, you want to do it that way. You want to use this form down here where I've listed the columns explicitly and then set the values in the order of this column list. Let's rerun our outer join query now. So I don't have to do anything other than go up and find our outer join query, our left outer join query. There it is. All right, so now when I rerun this same query, I get 78 rows instead of 77. We can find our tofu in there. Extra firm tofu. And you see that there are 0 orders for it. If I were to do this with an inner join, then it wouldn't include the extra firm tofu because there's no orders for it. With the outer join, I get the rows from the left side, the order, whether or not they occur in the right side, the product, whether or not they occur in the right side, the order details. So I get everything from here and only the things from here that match a row from here based on the product ID, which is the on clause, the product ID. So it was the same query last time, just now we have a 0 order item. So the whole point of this was that I could have at least one thing that didn't have an order. So now I can go ahead and delete my extra firm tofu, bye-bye. Let's say I want to drop a table. I want to delete the table, not just the records from the table. That would be the delete from. I want to get rid of the entire table, including its definition. So if I do that, I drop the entire US states table. And if you do DT, you'll see that the US states table no longer exists. And let's say I want to lose my entire database. If I want to lose my entire database, I'll just connect to a different database because I can't drop the one I'm in and type drop database Northwind. I left that out of the slide. Oh no, there it is. Drop database Northwind. And then it'll drop the Northwind database. I'm going to do that right yet. So the where clause in my delete statement is the same as in the select. Deleting by a primary key ensures I get just the one I wanted. Drop table drops a whole table. I connected to a different database because I can't drop the one I'm connected to. This isn't SQL, but a YSQL SH or PSQL thing. Drop the database Northwind drops the entire database, not just the data, but the table definitions. After that, you can't even connect to the Northwind database because it no longer exists. So what else should you learn from here? Well, first, we only covered a few functions. There are averages, min and max and more. There are other forms of outer joins in particular. We didn't cover the update statement. Maybe you want to rename tofu to extra delicious tofu. There are other statements we did basics. There are other statements, but we just did the basics. So we focused on the DML or data manipulation language of SQL rather than the data definition language. meaning we queried and inserted data, but we didn't really talk about how the tables are defined, though you can see them down here in the script. We didn't talk about indexes, but querying efficiently means understanding indexes and how they work. So if you were to go do this and put a bazillion records in it and start querying on certain fields and what have you, find things got slow unless you understood indexes and creating indexes. Also, we didn't talk about altering tables or other DDL concepts, data definition language concepts. If people like this webinar, I might follow on and go over this and more. But this is just a start. So Yugabyte's got a lot of learning path stuff, and at the above develop URL. So if you go to this docs.yugabyte.com/latest/develop, you can kind of take a path down the same trek. If you want to learn more about Yugabyte and what's new or keep up with current events, check out our blog at blog.yugabyte.com. And I'm happy to talk with you guys on Slack, so you can join the Yugabyte Slack or Twitter. I gave mine on the first slide. It's at AC Oliver. And you can check us out on GitHub if you're interested in how modern distributed databases work. So thank you guys, and I'm happy to answer any questions that you might have.
Hi, if you have a question on today's webinar, please head on down to the bottom of the Zoom window to the Q&A widget area and type your question there. Andrew, I do see that a couple questions came in while you were presenting, so if you want to go ahead and give them a look over and answer them, that would be great.
Sure. So the first one is, what does the update statement look like? Okay, so I'm glad I didn't drop the database. So I'll go ahead and show you that, guys, that one. So I'm going to connect to the Northwind database again, and I'm going to select from products where product name equals tofu, my original tofu. Oop. Oh, I did delete from. Select star from products where product name equals tofu. Okay, so here's my tofu. So if I wanted to change the tofu, I would say update the table name. So products set product name equal extra firm tofu, where product ID equals 14. And then now if I go back and say product ID equals 14, then I get my extra firm tofu. So I've updated it, and I was able to change the column name. If I wanted to change multiple column names, I would just put a comma and another, I would just delineate them with a comma, so I could say set discontinued equals 1, which would make me very, oops, set discontinued. I can't spell, but anyhow, you get the point. So I would just, sorry, I shouldn't have included the set again. Just say set discontinued equals 1, comma discontinued equals 1. So the update product set, and then the column list with the values that equals the values you want to change them to. I've been making that same syntax error since I first learned SQL. Okay, so do we have any, oh, sorry, how is the Yugabyte database different from PostgreSQL or Oracle? So both PostgreSQL and Oracle were really designed for a server that you're going to scale up. You're going to put faster CPUs in it when you want to go faster, and you might put more drives in it and move tables to different drives. You're going to add more drive controllers. In Oracle, you'll put the temp segment on one drive and the rollback segment on another drive. And that's how you're going to scale up. More drives, faster CPU, faster drives, one big server. There are clustering technologies, but when you go and look at them, they're not modern architecture. So when you actually want to scale, it gets really difficult. It can be done, but it gets really expensive and difficult to do so. Whereas YugabyteDB was actually designed that you can just add more nodes. So if you're looking for a cloud style architecture, horizontally scalable, that's basically what Yugabyte offers. And it comes from all the lessons learned from NoSQL. Our founders were part of the creation of the quote unquote NoSQL revolution, if you will. They took that lessons learned while they were building a better database later. So so it combines the concepts together. And are there any benchmarks around Yugabyte's performance? Absolutely. So if you're interested in benchmarks, we've got a few places that you can look. And I'm trying to turn off the page analytics here. So the first place that you can, I'm trying to turn off Google Analytics as I do this. So the first place that you can look is in the documentation. So if you go to docs.yugabyte.com latest benchmark, and you can find the different benchmarks. You can actually find how to reproduce them yourself, but they also give you some results in there. The other place that you can look is actually in the Yugabyte blog. We've got quite a few benchmarks that have run over time and compared to other databases that you might be interested in. And then what's wrong with generating a key by the select count statement? Okay, so we didn't talk about transactions or data integrity or concurrency or any of the kind of stuff that you would need to worry about in a large scale application. But essentially, if two of us execute the select count statement at the same time, then we'll both get back the same number. And then if we just increment it, we'll both try and create a duplicate ID. So that's not cool. There's something in traditional database, SQL databases called a sequence, which gives you a count. But the problem with a count is that it means that all the threads go down into a mutex, a lock, and they come out one by one. So if we've got lots of threads, that gets slow. So the traditional Oracle or PostgreSQL, SQL Server way of doing unique IDs is actually not good for high-end scale. So what you'll actually want to do, and I'm happy to cover in a later session, or you can check out on the Yugabyte blog, is you'll actually want to generate a UUID, basically a hash value of sorts, a unique identifier at random. And that will be unique, more unique. The chance of generating a duplicate is several orders of magnitude smaller than an asteroid hitting you on the head. So you won't get a duplicate very likely, and that goes at high concurrency. So that's actually the way you're going to want to do it. All right, guys, we're slightly over time, but I thank you guys for all of your questions, and I am totally happy to talk with you further on Slack, and let me know what you thought of this webinar. Hit me up on Twitter or send me an email, and I'm happy to do a follow-on if people enjoyed it. Thank you, guys.